Let's do tomorrow during lunch so you don't miss class. All right, here we go. Number 1. We have a fraction plus a fraction over a not fraction. What should we do first? Yeah, make the not fraction a fraction. Okay. Are you taking money off my desk? Okay. All right. What is the least common denominator between all of these? 5. Okay. So now I'm going to take this and I'm going to multiply by 5 over 5. So I'm going to do m plus 3 over 5 times 5. And 4m plus 2 over 5 times 5. Oops, I wrote times m, but I meant times 5. And m over 1 times 5. Is there any confusion so far? So I was able to multiply by 5 over 5 because multiplying by 5 over 5 is multiplying by 1. And when I multiply by 1, I'm not changing what it equals, right? I'm just changing what it looks like. Still equals the same thing. So I basically took this 5 and I distributed it. And took that 5 and I multiplied it right there. Okay? Any confusion so far? We good? Okay. So what happens to this multiply by 5 and this divide by 5? Oh, they cancel. That's nice. And what happens to this multiply by 5 and this divide by 5? Oh, they'll cancel. So on the top, we have m plus 3 plus 4m plus 2. All right, now we have a times 5 and a divide by 1, so on the bottom, they do not cancel. So on the bottom, we just have 5 times m. When you divide by 1, that doesn't really do anything, right? So we just have 5 times m. Yeah.
Why would we look for the... Oh, wait. For the LCD.
Yeah. So at this point, we used to have 3 fractions inside 1 fraction. How many fractions do we have now? We just have 1 fraction. All right, what's on the top? Yeah. 5n plus 5. If you canceled anything right now, you would kill puppies. Yeah, so don't cancel right now. Okay. So what should we do next? No canceling, no dead puppies. Factor. Okay, how do you factor the top? GCF, take out the 5. What's left over? m plus 1. Okay. You could cancel now without killing puppies. Cancel out the 5s. m plus 1 over m. Can we do any more canceling? No, we don't want to kill any puppies, so we're going to stop there. Okay. How do your brains feel? Okay. Yeah. Yeah, let's do 6. All right, look at all the denominators on 6. What do you see about them? They're all x plus 2. They're all the same. Okay, so the least common denominator on number 6 is x plus 2 because that's what all the denominators are. So we're going to say we're going to multiply by x plus 2 over x plus 2. Okay. So I've written down every single fraction times x plus 2. The x plus 2 on the top got multiplied by the top fraction. The x plus 2 on the bottom got distributed to each bottom fraction. So I'm multiplying by x plus 2 over x plus 2 because that's like multiplying by 1. And I'm allowed to multiply by 1 because I didn't change anything, right? Or I didn't change the value. Multiplying by 1 keeps it the same. Yeah. So the reason that we do this is because when we do this process, we take something that's a complex fraction. Right now we have 3 fractions in 1. And when we're done with this process, we're only going to have 1 fraction in 1, which is nice. It makes it easier to work with. So what happens when you're dividing by x plus 2 but also multiplying by x plus 2? They cancel out. What happens when you're dividing by x plus 2 but also multiplying by x plus 2? They cancel out. And then they cancel out again. So on the top, we just have x squared plus 5x. And on the bottom, we have 3x plus 15 plus x plus 5. So on the top, we have x squared plus 5x. On the bottom, we have 4x plus 20, and that is so much easier to work with than what it was before. So that's the benefit of what we just did. We got rid of all of those denominators, and we took what was 3 fractions and what looked really complicated, and we turned it into something a lot more simple. So what are we ready to do right now? Factor. And what type of factoring are we doing? GCF. So what's the GCF on the top? X. Okay. What's the GCF on the bottom? Then what do we get? Okay, and then what cancels? What do we get? Oh, that's so satisfying. So this craziness is actually just x over 4. Whew. It's wild. It's wild. It's wild. Stop it. Stop it, math people. You know who did that? It was me. I did it.
Yeah, but like I know you have to do your job.
Yeah.
Math world, why can't you just write?
Math people, come on, stop it. Don't do this to us. Rude. Boom. Boom. All right. Which one should we do next? Yes. We can do number 8. All right. Number 8. What is the least common denominator? 4x squared. Okay. Okay. So this one is interesting because, like the last one, it was nice. You divide by x plus 2 and you were multiplying by x plus 2, and it was a complete cancellation for every single one. This time, it's not going to be a perfect cancellation every time because what you're dividing by and what you're multiplying by is not the same. So this one's going to require a little bit more thinking each time. I'm going to give you guys a little bit of time to write it down. No, you're fine. I figured it out. I'm a smart person. He said, by the way, I'm not taking pictures of you. My feelings aren't hurt, Cal. It's fine. All right, so in the first one, what cancels out? The 4s. Divide by 4 and times by 4, that cancels. And so what are we left with? Yeah, 1 times x squared gives us an x squared. Okay? And then for the second one, what cancels out? And what are we left with? It's a minus 100. 25 times 4 is 100, so minus 100. Okay? And then on the bottom, what cancels out? Just an x. So we have 1x, cancels with one of the x's, and it leaves one behind. And then what are we left with? So 4x squared minus 40x. Okay? So now what do we do? Factor. So how do you factor the top? Difference of squares, and you get... How do you factor the bottom? And what do you get? Oops. So we undo the distribution that we just did. Okay. And what is our final answer? Do the x's cancel? No. Do not kill a little puppy. Okay, okay. Yeah. Oh no. I mean, it could be a typo. I don't think is it a typo? Is there?
Yeah, and there's no.
There's no. Oh no, Miss Rice. Oh no, Miss Rice isn't perfect. Shucks. That's probably it. All right, should we do another one? Is there one that looks scary? 5 looks scary? 12 looks scary? Do these still look scary? You guys think these are scary? 12 looks scary? Does 12 look scary? Does 5 look scary? You guys really think they all look scary? Let's do number 11 because we end up getting some stuff that goes backwards. Okay, number 11. LCD, what is it? 9m. Is it 9m? 9m squared. Okay. So we're going to multiply 9m squared over 9m squared. Okay. All right. First one, what cancels? M squared, and we get 9 times 9 is? Okay. Second one, what cancels? 9m and 9m, and what do we get? M squared. M times m is m squared. Okay. What cancels on the bottom? 9m and the 9m, and what do we get? Okay. And then when we start to factor this, should we leave it like this or should we do something? Okay, negative m squared plus 81 over m squared minus 9m. Okay, then what should we do? Take out the negative. Difference of squares. And then how do we factor the bottom? Yeah, so GCF, so we're just going back to what this was. All right, and so what cancels? So we get negative m plus 9 over m. Or you could say negative m minus 9 over m. Either of those answers is good. Can you? You'd kill a puppy. So the only way to cancel out parentheses is if you have parentheses that are identical. Okay. Are you ready to just kind of work, or would you like to see another problem? You're good? Okay. Answers are in the back, not to the punchline, but to the problems. I did not check them against the punchline. I just was doing the problems while I was on the phone with my neurologist, sitting on hold, saying, "Give me drugs, man. Give me drugs." As a joke. I have a geologist. I'm that person. I have a whole geologist on hand. So I'm that level of cool. All right. Also, I am planning my 3 days of getting a straight IV of drugs in my veins for my headaches. I'm planning that for fall break, so hopefully I will not have to be out for you guys. You're welcome. You sit there for 2 hours and they just put drugs in your system for 3 days straight, and it's $240 with insurance. But we shall see. Hopefully it will work. Schenkel.